should have some basic knowledge of types of energy. Stop it. Stop talking about John. You guys should have some basic knowledge of types of energy and non-renewable, renewable. Okay, so what I'm going to talk to you guys about is how you take specifically a non-renewable energy source like coal, petroleum, or natural gas and turn it into electricity. Okay? At some point, you guys will be tested on how this process works. So please make sure you take notes and pay attention to what I'm talking about. Okay? I can certainly give you guys my notes at some point if you want to look at my notes, but they're pretty intense. So, alright, so we start with numero uno, coal supply, okay? Or natural gas or petroleum, okay? The coal is actually brought in and ground up into a really fine powder and pushed into the boiler here, okay? If it was natural gas or petroleum, it'd be piped in, okay? Because it's a liquid or a gas, so it wouldn't work in the same way. Okay? So that's piped in, tossed into the boiler. It heats up to like 1300 Celsius, which is really, really hot. It's like 2000 degrees Fahrenheit. Question?
I'm just gonna say, isn't it after the water boils, it turns to steam?
Don't get ahead of me.
Wait, what? Wait. How?
Shut up!
Up to about 1300 Celsius.
It literally shows right there the word steam line.
Yes, it does. That's very good deductive reasoning, John. Next, it turns to steam. Sort of. John has the right idea. He kind of has an idea of where this is going to go. My question to you guys is, what type of energy... I'm going to type it up here, actually. No.
Does it actually say something?
Yeah. Okay, hopefully you guys can read that kind of. So this first step here, where the coal goes into the boiler, potential energy. What type of potential energy?
Gravitation.
So it's some.
Yes.
Do we remember what coal, natural gas, and petroleum are in terms of? Excellent. Energy stored in the bonds of atoms. Chemical. I'll do all caps. Let me read it a little better. Chemical potential energy. Okay? So that's our step one. Chemical potential energy.
Potential.
Okay? This is the other part of it. Besides knowing the process, this is the other part of it I want you guys to know is where kinetic is and where potential is and the types of energy that are going into this. Okay? Who needs a couple more seconds on this to write it down? Okay, so our chemical potential energy gets ground up into a fine powder and dusted, blown into this boiler here. Okay, where it is heated, where it burns rapidly and hot at 1300 Celsius. Okay, it's weird that you're doing that, but when that boils, these little guys here, there are many kilometers of pipes that are filled with purified water. Okay? Let us imagine pipes lining this boiler that are filled with water. What happens to that water, John?
I get heated up and turned to steam.
It turns to steam very quickly. Okay, so step two, where it's heated, what type of energy? Like that coal burning, kinetic or potential?
Thermal.
Yes. Yes.
Oh wait, I got it.
I agree with thermal. Thermal, kinetic, or potential? Does it? Because it's hot, is it necessarily moving?
Kinetic.
No.
Potential. What does that even mean?
It's
Why is
potential,
that
isn't it?
Those are the two forms of energy we deal with. Okay, I haven't heard
I think it's kinetic.
for sure.
The potential. Kinetic potential. That's not
First of all, my question to you guys is, thermal energy is the heat or internal energy of a substance, right?
Yeah.
So my question, does that have anything to do with it moving around?
No, it's potential.
Necessarily. Okay, I agree.
So that's what you want to say.
Y'all will.
Yep, I got that one.
That's okay. All right, put that in here. That's step two. I don't know if it's squeeze it in there. Okay. So thermal potential energy is where, not with the steam, but with the 1300 degrees heated coal. Okay, so the coal itself has thermal potential energy. So we're at the point where we've got many kilometers of pipes that line the boiler. Steam moves at high speeds down the steam line to the turbine, okay, which is labeled. Okay, so now, I just said steam moves. Okay, so at this point, the steam is definitely has some kind of kinetic energy.
Mechanical?
I think we can just call it motion kinetic energy.
Did I just make that word up, mechanical?
No, you did not. No, because we will have mechanical energy shortly. But this steam moving really fast through here, is going to catch these turbine blades and cause the turbine blades to move.
Like on a.
Okay? So then my question is, for the next one, that's kinetic energy, right? Because the turbine blades are moving. And but it's turbine blades. It's a physical
Stored.
thing. It's not stored, but it is mechanical. Okay, and I'm going to label that as step 4 shortly. Okay, so just backtracking a little bit. Our coal gets ground into a little powder, gets shot into the boiler where it burns really, really hot at 1300 degrees Celsius, which heats the tubes of water. They're purified because if they're not purified, then that leads to corrosion and stuff like that, so they have to use purified water. Which then is kind of shot, I think they kind of bottleneck it, so it gets shot into these tubes up here. And because they're moving fast, they catch the blades of the turbine, which then that turns it into mechanical, I didn't spell mechanical right, mechanical kinetic energy. Okay, so those turbine blades are spinning.
Mechanical.
Yeah, I did. That's what I'm,
It didn't look right to me.
yeah,
It's
there.
It's not
Mechanical. Okay. So, one might logically assume that the next step is the generator, which that would be correct. Okay. There's a little, I'll try and point like right there. There's a little metal rod that connects the turbine to the generator. Now, inside the generator, I can try and draw you guys a little picture, but I would rather not because it's kind of complicated. What's inside the generator? It's orange coils of copper wire. Okay? And so inside it, hold on, I can do this. Inside it is a nice big electromagnet. Okay? Yep, this is good stuff. I'm drawing with a mouse pad. It's really awesome. Okay, so there's copper wire that surrounds an electromagnet. Okay? I don't know if it's super obvious that that's a magnet, but, you know, I do what I can with a mouse pad. You know, do what I can, kind of. Electromagnet, copper wire. Okay? So that's the inside of the generator. I'll draw a little arrow here. That's the inside of the generator. Okay?
Nice arrow.
You know what? I think that's actually pretty good.
I was being serious.
Yeah, no, I agree. So inside the generator is an electromagnet. Those turbine blades that are connected to the metal rod are connected to that electromagnet. When you spin an electromagnet, it makes electrons move.
No way.
Way. My question then, if electrons are moving, what type of energy is it?
Kinetic.
More specific.
Kinetic motion. Mechanical.
Motion. Stored mechanical.
How is it
Oh.
stored in kinetic?
You're electrical.
You just said kinetic.
I think I heard it.
Oh my God, I was right.
Yeah, I think I heard it.
What's step 5?
I thought that wasn't even a word.
The generator.
Step 5, they're both words.
No, I meant.
Okay? So just backtracking again, the turbine blades are spinning, and they're connected to that electromagnet, which causes the electromagnet to spin. If the electromagnet is spinning inside of a copper wire, or really any wire, but more specifically copper, because that's a really good conductor of electrons, when it's spinning inside copper wire, it aligns those electrons really nicely, and then those copper wires then go out here. And then just going a little further than that, the transformer down here is what amplifies the electricity. It turns the amps up, it increases the voltage.
Interesting.
It increases the voltage. It takes the energy you have, increases the voltage, and then the transmission lines, hopefully obvious, the transmission lines are what go to substations and to different cities and towns.
I have learned something.
Step 6.
Okay, so that would be our step 6. But there's no change in type of energy and kinetic or potential. It's still kinetic energy going from transformer to transmission lines. That's just extra information for you guys. And then, of course, you know what I want to add here? Because I'm environmentally aware. I'm just gonna point out, since forever, I recycle. Okay, I'm just gonna point out here that this stack here, in general, coal plants and stuff will do a pretty good job of like collecting the ash from burnt coal. There's like heavier ash that will fall to the bottom of the boiler here, and there's stuff called fly ash that they filter here. This little that's a filter there that will kind of trap the fly ash and knock it back down. So they collect fly ash and send it off to a landfill. But other emissions, such as CO2 and and SO2, that's an S. No, it's because it was. SO2 is sulfur dioxide, and NO, nitrous oxides.
What's 5?
That's an SO2. I'll put a little plus in here.
But what's the number 5? Like below 4?
Electrical kinetic energy.
Is there going to be anything on
What's
that?
the NO?
NO is nitrogen.
NO is no.
Nitrogen oxides, nitrogenous oxide, nitrogen monoxides. Yes, it is. No, it is. I'm just not saying it right. Okay. So, I just want to point out that this method is good. It produces electricity, but it also produces pretty nasty emissions. Yeah, smog. Mostly carbon dioxide and sulfur dioxides, but also some. It depends on the waste. Okay, but coal is basically carbon, so it produces carbon dioxide. Okay.
That's so many trees.
So with that, okay, that is our how coal, natural gas, or petroleum, how any of those three really become electricity and then come and power this computer and this laptop so that I can then teach you about how it works. Okay?
You're creating smog,
I am.
Miss Lehman.
There's another one?
Wait, yo, what is this? I don't have this.
So,
I don't have that.
alright, no, you don't have this one, but I want to point this out. This is EcoMaine. This is their waste energy generator.
So I don't need to record.
Okay? This actually has the same thing. They have trash, they put it into the boiler, it becomes steam. The steam turbine generator then puts out electricity. But then what they do, which I am really impressed with, is this down here, their pollution control system. They remove nitrogen oxide, mercury and dioxin, acid gas, and other particulates. Like these filter system here, basically all they put out is a little bit of CO2 and mostly water vapor. Because they work really hard to make sure